Welcome to Layer 1 with Vijay. This is a 12-part series on the generative AI. As part of that series, last week we have started with our episode 1. So there we have shown the Gen AI evolution. In that we have covered the 5 concepts starting with data science, then computer vision. Later we have covered the natural language processing. Then a big leap in 2017, that is generative AI. It doesn't stop there. It started taking action. Welcome to episode 2, How Machines Actually Learn. Here we are going to answer my one of the curious thing, what happens inside the machines, how is able to learn, what is meant by learning. I was 12 years old when I started learning bicycle. It was not a easy ride. I was falling to the left, then slowly adjusted to the right side, then falling to the right, then again slowly adjusting to the left. Slowly, after making so many these tiny adjustments, finally I started learning. But one day what happened? I have gone with full speed, but brakes did not work. I fell hard. It was a small accident happened that time, but the learning, it did not fall with me. It stayed till now. This is the idea behind all of modern AI. This is the learning. We made a mistake and we measure how much we are wrong. Then we adjust slightly, as I told, towards the right, towards the left. Then finally, after doing so many kinds of repetitions of thousands of times, sometimes it takes millions of times for a machine to learn. So these are the 4 words we are covering in the whole episode. This is what learning. But how does anything can learn? Imagine a child is learning about a dog. We show her pictures of dog. This is dog. That is not dog. Do you really teach through a definition? It has 4 legs. It has a fur. None of that, right? We show her a lot of pictures. Slowly brain starts recognizing, builds a pattern. Next time when you show some hidden piece of the dog, some different breed, naturally we tell that it is dog because already brain builds a pattern. A machine does exactly this. So this we call supervised learning. We feed so many examples. This is dog, this is number 3. Then a pattern emerges. Next time when you show any unseen input, it can confidently tell that this is the correct output. This is how we learn and this is how the machines learn. What is about training the machines? This is the 5 steps, one loop, repeated thousands of times. Bingo, it can produce the correct output always with some probability. First, it makes a prediction. You show a machine some handwritten number 3 or a cat. In this example, we have shown number 3. Inside the machine, there are weights. Don't worry, that we are going to cover. But it guesses number 7. It is wrong. Then we are measuring the loss. We have shown the correct number. You have produced 7, but the correct number is 3. The gap between 3 and 7 is called loss. The higher the loss, stronger the signal. Now, what we do in algorithm is somehow we back propagate this information, this loss through each and every layer to the first step. Each weight learns how much it contributed that error. The 4th is gradient descent. Every weight nudges slightly in the direction to reduce the loss. Very tiny, very precise. 5th is repeat. Now we show some other number, then again it predicts something wrong. Then we measure the loss. If the loss is very high, this is the stronger the signal. Again we send that loss back. You made a mistake. You adjust the weight slightly. So like how in the example of our cycle, when we are falling to the left, the brain tells that you should go towards right. It's a tiny adjust. So same thing happening over and over and again. So make a prediction, measure the loss, back propagate that loss, adjust that loss through gradient descent, then finally repeat with the new examples. Same loop after millions of times, the weight stabilize. Then next time when you show the unseen photo or unseen number, handwritten number, it predicts correctly. What is actually being adjusted? Think of a radio knob. When we were kids, we had a radio, BBC or something. We need to tune to get the frequency right. Then it plays songs correctly without any disturbance. The same way machines has weights. How the radio has that knob, tiny knob, we tune it to get the correct channel. The same way every machine has weights, but the radio has one knob, machine has thousands or millions or trillions of these weights. How one weight works? In the previous example, we have shown the handwritten number 3 that we have taken as a photo. We are feeding into the machine. The photo is nothing but the pixels representation. But let us say one pixel is having value of 0.1 1.8. We are multiplying the weights. Then it produces some kind of signal. This signal passes to the each and every layer. Then finally it produces number 7. The number 7 is wrong. Then what happens? The pixel value is constant because our whatever produced handwritten number taken into the image, that is having 0.8 value, one of the pixel value. That cannot be changed. Only variable here is weight only we are changing. We are changing the weight based on the how much loss we have encountered. It is not 0.3, for example, weight. We increase it to 0.4 or 0.5, very tiny weight. Then the signal is strong enough so it can predict it is number 3. In this example of 28 by 28 image, we have 784 pixels. Then in the first layer itself, we have like 12,000 weights. But in case of GPT-4, how much you know? This is 1.8 trillion weights. Unimaginable large scale. These are the weights which are contributing to predict the correct output. How does it know which way to adjust? I have got a loss. It's a very strong loss in the back propagation, informing every layer right from the first layer to the last layer. It has to be adjusted. But how it knows that which way to adjust? There is a beautiful mathematical concept called gradient descent. Imagine you are on a top of a mountain. That is representing the high loss. Here you see the red dot. That is your top of the mountain. Now you need to find out a valley below the mountain. This is the lowest valley. So that is where you have to go. That is where the loss is very less. That is our goal. Finding the lowest loss is what gradient descent does. That is what the weights adjustment. Here you see the bicycle parallel example. You are nearly falling to the left. That is a high loss. Then body tells that you need to turn towards right. So that is what gradient computation. We do the tiny adjustment towards the right. This is what weights are nudging. Finally balance achieved and loss is minimized. Same idea, let us see with real network what happens. Are you ready for the live demo? You see the left side, just we are training with some digits, and network state is before the training and after training, hidden layers, and this is the output layer. This is having 10 neurons equivalent to for representation of the 10 digits. The right side you can see the predictions. Initially these lines, they are the weights. As I told, the radio knob tuning the frequency, they are garbage. Nothing is tuned, no knowledge is present within these weights. Any 0, 1. So nothing is happening within the network. This is before training. Now let us see in the normal speed the train network. So what happens using the back propagation? Here we have given 5, but it is giving 4. With the back propagation, it tells the previous layers the weights will be adjusted. You can see how these will be light up, how quickly it happened. Here the loss also reduced to very minimal. Now if I give any number 5, 3, so it is correctly predicting. Let us go very slowly step by step so that you will again have a chance to see. I am going in the manual mode. Now I have given 3, it is predicting 7. So first step, what happens from the 7, we are telling that it is not 7, it should be 3. So the back propagation starts, the lines that is represented by the weights, they will be thickened, and the neurons also currently is not firing. So the neurons also will start firing. You can see I am clicking on the first step. Then you see some of the neurons already have thickened. So slowly the probability distribution also getting changed in the right side. So we are going very slowly. So you see the number 1 is gaining the probability, and you see the how the weights distribution is happening in the real time, and how some of the neurons are getting fired up. They are having the knowledge now. So with each pass, the probability is getting higher and higher for the correct number. Now I'm completing with the auto loop. Now training is completed. You see how the beautiful the network is, everything is lightened up. If I give any number, correctly now predicts because network is having full knowledge. So that is about the live demo today. I hope you understand what we just now described now with visual representation. This is the result. Before training, all weights are random. The output is a random noise. We show the number 3 predicts number 7. We show some dog, it predicts cat. But after training, the weights have organized, weights are adjusted, output is consistent, patterns have emerged. We have shown 3, it predicts 3. We have shown unseen dog, dark lit dog, or some different breed, and it still shows correct. This is what before training and after training. Back to the bicycle example. When I finally balanced, I could not explain how. My body just knew. A trained machine is exactly the same. After millions of adjustments, the weights settle into values that work. The knowledge is distributed across billions of numbers. In the GPT-4 example, it is mind-boggling 1.8 billion parameters. That is where knowledge resides. No single weight means anything. Together, they produce the right answer. So quickly recap what you now understand. It's a supervised learning. You give labeled examples, machine finds the pattern, it generalizes to the unseen inputs. The training loop attempts, then it gives the wrong because the weights are garbage. We measure the loss, then we tell that you made a mistake, you correct it now. That means correction is weights adjustment using gradient descent. The same thing repeats after thousands of times, millions of times, it produces and it predicts correctly. This is time to test your understanding. Just 3 questions, answer this. Anywhere you are faltering, revisit the sections you didn't understand. Now you know the engine behind every AI system. The next episode is about the natural language processing pipeline. You know now how machines learn. Episode 3 answers how does a machine handle words? Words are not numbers. So how do you teach a machine to read? So this is about episode 2. If you like this episode, please subscribe and like this video and comment to make me better. Thank you all. Peace.